Welcome to the online training session on the topic of energy and greenhouse gas emissions. This is the last topic within Principle 3, Natural Resource Conservation of the Sustainable Agriculture Standard. Although there are only 3 criteria on this topic in the standard, it is important to understand the bigger picture of climate change to implement these criteria. Therefore, this session will first explain the mechanisms of climate change and the different types and sources of greenhouse gases. Secondly, it will give examples on how to reduce greenhouse gas emissions on your farm. Have you noticed that the climate has been getting strange in the past years? Let us see the mechanisms of climate change in a very simple manner. In the history of human activities, especially after the Industrial Revolution, human beings started to burn a large quantity of fossil fuels such as petroleum, carbon, and natural gas. Many industries have burned fossil fuels for production. Vehicles need petroleum. Forests have been destroyed for agriculture and other purposes. As a result, a lot of gases called greenhouse gases have been emitted into the atmosphere. Once these gases are emitted, they go up in the atmosphere and cover the Earth like a thick blanket. When there is a blanket of greenhouse gases in the atmosphere, the heat from the sun is contained under this blanket. When the heat from the sun cannot escape and accumulates, the Earth gets hotter and hotter. As the temperatures rise, wind patterns and rain patterns change, and various climate disasters start to happen. Let us understand different types of greenhouse gases and where they are coming from. The first important greenhouse gas is carbon dioxide. It is emitted through deforestation, through use of vehicles such as buses, trucks, airplanes, and cars, through use of firewood, when generating energy by burning fossil fuels, and by industries. Carbon dioxide is the most emitted greenhouse gas, and it accounts for over 80% of total gas emissions. The next greenhouse gas is methane. Methane is emitted from cattle production, as cattle dung and burps produce a lot of methane. Waste and wastewater are other sources of methane. Methane emissions is less in quantity as compared to carbon dioxide. However, it does not mean that it is less important because methane can heat the Earth 21 times as much as carbon dioxide. 1 molecule of methane in the atmosphere is equivalent to emitting 21 molecules of carbon dioxide. The next important greenhouse gas is nitrous oxide. Use of nitrogen-based fertilizer in agriculture is one of the important sources of nitrous oxide. Burning trees, grasses, and crop residue also emits nitrous oxide. Nitrous oxide is also less in quantity, but it is very potent. 1 molecule of nitrous oxide in the atmosphere is equivalent to 310 molecules of carbon dioxide. It can heat the Earth 310 times as much as carbon dioxide. The last category of greenhouse gas is fluorinated gases, such as hydrofluorocarbons and sulfur hexafluoride. Refrigerators and air conditioners are 2 most important sources of hydrofluorocarbon emissions. These devices use hydrofluorocarbons as a coolant, which leaks out slowly over time. Aerosol sprays is another source of hydrofluorocarbon. Electric power industry uses sulfur hexafluoride as an insulator and also for the transmission and distribution of electricity. Emissions occur through leakage and maintenance losses. There is another fluorinated gas called perfluorocarbon, which is usually emitted by the aluminum industry. These gases are small in quantity but are extremely potent. For example, 1 molecule of sulfur hexafluoride is equivalent to 23,900 molecules of carbon dioxide. Wow, that's powerful. You may think that agriculture is not an important source of greenhouse gas emissions, but let us look at this Venn diagram. Agriculture accounts for 13.5% of the total gas emissions. If the land has been deforested to conduct agriculture, its greenhouse gas emissions belong to this category. Agriculture produces waste and wastewater. Processing facilities such as mills, factories, and pack houses use energy such as electricity and firewood. We often use trucks in agriculture. There may be worker housing on the farm. Therefore, many aspects of agriculture contribute to greenhouse gas emissions. From the next slide, let us look at each of these categories one by one and see what we can do to reduce the emissions of greenhouse gases. How does deforestation emit greenhouse gases? Forests and the soil under the forest cover store a huge stock of carbon. When trees fall, the carbon that was stored in the trees is released through burning or through decomposition. The soil that lost the forest cover also releases a significant amount of carbon. The carbon that has been released gets together with oxygen and forms carbon dioxide. This is how deforestation significantly contributes to greenhouse gas emissions and therefore to climate change. Then, how does reforestation help? When there is a tree, it absorbs carbon dioxide in the atmosphere, stores carbon within, and emits oxygen. Trees play a crucial function in reducing carbon dioxide in the atmosphere and mitigating climate change. What can we do to have more trees on Earth? You can plant native trees on or around your farm. You can plant native trees as shade trees. If there are patches of forest on or near your farm, you can make it a conservation area and protect the trees there. If you are buying fuel wood, you should ensure that you only buy wood from sustainable sources and do not buy wood that is acquired through deforestation. You can find more details on this topic in Module 5, Native Vegetation. Please visit the module to learn various ways to increase the areas with native vegetation and trees. Now let's look at the soil. How does soil erosion contribute to greenhouse gas emissions? Soil also stores a huge amount of carbon. When the soil is exposed to the air through deforestation or soil erosion, the carbon in the soil get together with oxygen and form carbon dioxide. This is how soil erosion contributes to climate change. Then how does soil conservation help? When the soil is covered with mulch or grasses, it increases organic matter in the soil, which stabilizes the carbon in the soil so that it does not get together with oxygen easily. This is how the carbon stock can be maintained in the soil. You can find the details on the topic of soil conservation and management in Module 7. Please visit the module to learn more about soil conservation techniques to reduce greenhouse gas emissions. What about fertilizers? Let us look at the mechanism. When nitrogen-based fertilizers, such as urea and NPK, is exposed to the air, the nitrogen in the fertilizer gets together with oxygen in the air and forms nitrous oxide, which is one of the greenhouse gases. How can you prevent the formation of nitrous oxide while still applying fertilizers? You need to apply the right type of fertilizer at the correct quantity at the correct time and in a correct manner. This is the correct method of fertilizer application. You first dig around the crop and place fertilizer. After placing fertilizer, you cover it with the soil so that it does not get in contact with the air. Compost should be applied in the same manner. If your soil is mulched, you can remove the mulch and place the compost around the crop. Then cover the compost with mulch so that it is not exposed to the air. You can find more details about fertilizer management and correct method of application in Module 7, Soil Conservation and Management. What about waste? Let us see how waste emits greenhouse gases. When waste is burned, it emits greenhouse gases such as carbon dioxide and nitrous oxide. When organic waste is heaped or left piling up, it starts to decompose without oxygen and generates a lot of methane. Therefore, bad waste management contributes to greenhouse gas emissions. Then what should we do? Good waste management is the way not only to get rid of sources of greenhouse gases on your farm, but to convert them into resources that help you reduce your energy consumption. Let us see examples. On this farm, cow dung is collected and used to produce biogas. Cow dung is no longer a source of greenhouse gas, but it now helps reduce the use of firewood for cooking. On these farms, biogas is produced on a bigger scale, using crop residue and waste from processing. Crop waste and animal waste can be turned into compost. Compost should be regularly turned so that it is aerated and less methane is produced. Through composting, organic waste can become organic fertilizers for your farm. In this last example, you see a coffee farmer using coffee husk as a fuel to run his processing machine. If you wish to become an expert on the topic of waste management and learn from good examples from all over the world, please visit Module 13, Waste Management. Wastewater is another source of greenhouse gases. When untreated, wastewater is stagnated at one place, and it emits a large quantity of methane. When you generate wastewater at your farm, it needs to be treated immediately. Treatment systems need to be adequate for the volume of wastewater you generate and the type of wastewater. You can learn about various kinds of wastewater treatment in Module 9, Water Quality. We use electricity in many parts of our lives. How is the electricity generated? Currently, the most common method of energy generation is combustion of fossil fuels. Fossil fuels are energy sources that can be found underground, and the top three fossil fuels are petroleum, coal, and natural gas. Electricity is most commonly generated by burning these fossil fuels, which emits a significant amount of carbon dioxide into the air. However, burning fossil fuels is not the only way to generate electricity. It can also be generated from renewable energy sources such as the sun, water, wind, and waves. Use of solar panels is a great way of generating electricity from the sun. For smallholders, there are solar panels that are small, portable, and low cost. You can leave it outside to charge during the day, and you'll have enough electricity to keep your room lit at night. If you are using firewood for cooking, you must be busy collecting firewood all the time as it goes really quickly. You may also be suffering from smoke that fills up your kitchen. Then an energy-efficient stove may change your life. There are many designs, and it can be made of locally available materials and at a low cost. It contains heat from the firewood, so all the heat generated is efficiently used to cook your food. You will be surprised how little firewood it consumes to cook the same food. You will also be relieved that the smoke is now exhausted from the chimney, so you can breathe properly while cooking. It will significantly improve your health. By implementing an energy-efficient stove, you can not only reduce the emissions of greenhouse gases, but also save your time and money and have better health. In this session, we have looked at many practices to reduce the energy consumption and reduce the emission of greenhouse gases. Please choose the ones that suit your condition and that you plan to implement in the coming years. Then, please write down how much energy you're consuming now and set targets for the reduction of energy consumption in the coming years. That's your energy efficiency plan. When you implement the activities that are in your plan and really achieve the reduction of energy consumption, you have complied with criterion A 3.46 and helped to mitigate climate change. Congratulations! Many of our daily activities emit greenhouse gases and contribute to climate change. Let us practice climate-smart agriculture to reduce the greenhouse gas emissions as much as possible and help this planet stay cool.